Today, we will be talking about uncertainty in measurement. We will start with the concept of precision versus accuracy. Precision is a measure of how closely individual measurements are, and accuracy is how close they are to the true value. As you can see on these targets, the first one shows good accuracy and good precision. The second one shows poor accuracy because it's far away from the middle, but it shows good precision because all three darts are in the same area. And the last one shows poor accuracy and poor precision because all three darts miss the middle mark and all three darts are away from the same area. Now we will talk about the concept of significant figures. Significant figures help us to get the answers that we want when doing mathematical problems. Significant figures include all digits of a measured quantity, even the uncertain ones. And to determine significant figures, we count the numbers from left to right, starting with the first non-zero digit. However, when counting significant figures, the zeros may or may not be significant. We will talk about this later on in this slide. Zeros that are between non-zero digits are always significant, as you can see in the example 4005. The two zeros in between the 4 and the 5 are significant because they're surrounded by non-zero numbers. But zeros at the beginning of a number are never significant, as we see in the example 0.02. There's only one significant figure, which is the 2. Zeros at the end of a number are significant if the number contains a decimal point. So if we change 0.02 to 0.0200, we now have 3 significant figures instead of 1. Now we will speak on significant figures in calculations. For addition and subtraction, the result has the same number of decimal places as the measurement with the fewest decimal places. The key phrase in there is measurement with the fewest decimal places. For example, 2.22 plus 4.2 equals 6.42. But since the lowest number of decimal places is in the number 4.2, then our answer should also only have one decimal place. So the correct answer would be 6.4. Now with multiplication and division, this differs. For multiplication and division, the result contains the same number of significant figures as the measurement with the fewest significant figures. The key phrase is the measurement with the fewest significant figures. For example, we do 6.221 times 5.2, the answer we get is 32.3492. But the lowest amount of significant figures is 2, which is the number 5.2. So the correct answer is 32. Now we will talk about dimensional analysis and conversion factors. Dimensional analysis is a mean of aid while we're doing calculations. It allows us to multiply, divide, or cancel out units. A conversion factor is a fraction whose numerator and denominator are the same quantity expressed in different units. For example, 2.54 centimeters converts to 1 inch. This is a conversion factor. A simple formula for solving a dimensional analysis problem is this. You take your given unit and you multiply it by your desired unit divided by the given unit, and it will give you your desired unit. We use this when we want to change from one type of measurement or quantity to another type of measurement or quantity. For example, if we want to change our mass from pounds to grams, this is how we would do it. I weigh 200 pounds. There are 453.6 grams per pound, so we will multiply 200 times 453.6, and it will give us 9.07 times 10 to the 4. Notice that our answer has three significant figures, 9.07, because this is multiplication and our number with the lowest significant figures is 200.